All right. So, hello and welcome everyone. We are live right now. I hope I'm audible to all of you. Okay. So, welcome back to this amazing platform of Tutee learning. And in today's lecture, we're going to discuss about the AD under the curve. Right. Hi, Reddy. Okay. So, welcome back. And if you're into this particular channel, then please subscribe to the channel and also hit the bell icon to never miss out any upcoming notification that is basically there that is put up on this particular platform, right? So this is a YouTube channel which is basically helping you out for preparation of the IIT JEE as well as other competitive examination with 10+2 level. Yeah, I'm good. Gurjot Singh, I haven't talked about anything right now. So we're basically going to discuss about the area and the curve, right? So, and if you haven't watched the previous lecture, then I would request all of you to please go back and watch the previous lecture and then you come to this particular lecture, right? So if you search, if you go to the channel and you find the playlist, you will see that there has been a lot of lectures that has been taken up for the JEE mains and advanced examination. So go to the playlist and find the lectures on definite integrals, indefinite integrals, and area under the curve, right? And then you come to watch this session, then only it will be clear and useful for all of you, right? So with this particular thing, let's get started. So I gave all of you a homework to practice. So let me know in the live chat, have you tried to solve this question or not? How many of you have been able to solve this question? Let me know in the live chat. So, so if you look at this problem over here, in this problem, we have been given a function which is defined as maximum of out of these three functions. Okay, so whatever function is maximum in whichever interval, we have to take that particular function and then we have to find the area in the curve between x equal to 0 to x equal to 2 pi, right? So if I try to see the solution for this question, so if I try to see the solution, y is equal to f of x, y is equal to f of x, which is given as maximum of sin x, comma cos x, comma half, right? So out of these three function, we have to find out that which of the following will be the maximum and in which interval, right? So that will actually give me the help me to draw the curve of this particular function, right? So let me try to draw the curve. Okay, so if I try to plot the curve between the interval 0 to 2 pi, so I am trying to draw that curve. Let us say this is a pi by 4, pi by 2, 3 pi by 4. Okay, before that we will also have so I'm trying to find out those particular points where these particular values are equal. So sin x and cos x is equal at pi by 4. Similarly, cos x is equal to 1 upon 2 or sin x equal to 1 upon 2 at 5 pi by 6, right? 5 pi by 6. So those are all values I'm trying to mark over here. Similarly, at pi by 3 also sin x equal to half, right? So I'm trying to mark all those values, and similarly pi, and we'll have another 5 pi upon 3, right? 5 pi upon 3. Okay, 5 pi upon 3, and at the end we will have 2 pi, right? So these are the all the intervals that I need to be careful about, right? So if I look at a first interval going from 0 to pi by 4, 0 to pi by 4. So what I see that at pi by 4, sin theta and cos theta is equals to 1 upon root 2, right? 1 upon root 2, which is greater than half. So if I try to first of all plot the half, y is equal to half, this is something like this. I'm drawing it with a dotted line. Okay, and then the cos will be higher than sine because sine is basically like this. So let me take a different color for sine curve. Okay, so sine curve will be given as this, and again at pi will be 0, and again at over here somewhere like this. Okay, I hope this is clear. This is a sine x curve, right? This is a sine x curve. Similarly, for cos x, the curve is like this. So it will start at 1 and will intersect at pi by 4. So let me try to draw this much better way so that I can. Okay, okay, something like this. Oh, Okay, please ignore the diagram I'm trying to draw, but I hope you can understand, right? I'm not sitting with a graph paper or pen and pen, so it might not be very accurate, but I hope you will get the feeling, right? So this is a cos graph. So it's starting at 1 and going like this, and again at pi by 2 it is 0, and at pi it is minus of 1, and then again at so somewhere over here 3 pi by 2 will increase, and again at pi 5 pi by 3 it will be equal to half, and then it will be increasing up till 2 pi, right, like this. Okay, so this blue curve denotes y is equal to cos x, and this yellow curve denotes y is equal to sin x, and this dotted line denotes y is equal to half, right? So if I try to plot, if I try to see the region which is maximum, so in this first interval this is my actual curve, so this is my actual curve. In the second one, this is my curve, right? In the second one, this is my curve, right? And in this interval, this is my curve. And in the final interval, this is my curve, right? So ultimately, what I'm getting over here is that the maximum function of these three curves is going to give me some curve like this, right? So first it is cos, and then it is sine, and then it is x equal to half, and again it is cos, something like this, right? So I hope you will take the note of the intervals. Okay, please take a note of this interval, and I hope the things as rest are easy, right? Rest is easy. Okay, so these are the intervals in which the function is maximum. So this is the actual graph of the function y is equal to f of x. So this is the graph of the function y is equal to f of x, right? Now I have to find out the area bounded by this particular region, right? So the area that is bounded by this region is basically this particular area, right? So be careful when you're integrating, you just put the limits and the given function. So therefore, if I try to integrate, or if I try to find out the area, so if I try to find out this particular area, so from the interval 0 to pi upon 4, it is integration of cos x dx. In the interval pi upon 4 to 5 pi upon 6, it is integration of sin x dx, right? In the interval 5 pi upon 6 to 5 pi upon 3, it is integral of half, and the last interval, the final interval from 5 pi upon 3 to 2 pi, it is integration of again cosine of x, right? So if you do this, if you carry out this expression and you calculate the value, the final answer to this question is going to come out as, so the final answer that I'm writing over here is going to be the final answer, that is 5 pi upon 12 plus root 2 plus root 3. This is going to be a final answer, square units, okay? Square units, because it is area, right? So I hope this is clear to all of you. How many of you are getting the same answer? Please let me know in the live chat. How many of you are getting the same answer? Please let me know in the live chat. How many of you are getting the same answer? Are you all getting this answer? Please let me know in the live chat. Please let me know in the live chat. Are you all getting the same answer or not? Okay, so once you confirm, and please try to solve it again by yourself, so that you can also do this kinds of question up in the examination. Okay, so these kinds of question is very useful, especially if you're preparing for JEE mains. Okay, in JEE mains you can see these kinds of question has been repeated a lot of times. Okay, so please try to solve this question on your own, so that you can understand and try to solve this question in your examination. Okay, Ekta, no, mine is different. Like, check it again. Okay, check it again, Ekta. Please try to solve it again. You will get the same answer. Creative Master Official, defer. Please check it again. Please check your calculation. Okay, this is the final answer. Okay, this is going to be the final answer. Please check your calculation again. Okay, in the first interval, it is the integration of cosine of x is basically sin x, and when the limit 0 to pi upon 4, so this is going to give you 1 upon root 2, right? In this particular interval, so integration of sin x will become minus of cos x, and if you put this limit, this is going to be equals to minus of root 3 by 2 minus of half 1 upon root 2 and a negative of that, right? And similarly, in this interval, it is half times pi upon 3 minus pi upon 6, right? And in this last interval, this is basically equals to root 3 upon 2, right? So you can check it. Okay, please try to check it again. You will get this answer only. Please check it again. Please check your calculation. Okay. Please check your calculation. You will get this answer. Okay. I hope this is clear, right? Is this clear for all of you? Please let me know in the live chat. Just let me know yes or no so that I can proceed with the next question. Okay. So in today's class, we're going to proceed with solving different types of example questions, and we're going to also see that what are the different methods or techniques to attack or solve any difficult problems, right? So whenever you see any questions in examination, how you can solve those questions easily and quickly, that is also something we're going to be seeing in this particular lecture as well. Okay. I hope this is clear to all of you. Is this clear to all of you? Please let me know in the live chat. Ekta, checking again and again, but my answer is different. I think I did some silly mistake, but I don't know what it is. I have already given you the hint, okay, Ekta? Can you check again? See, I have given you the hint, okay? Please check the calculation by putting these values. Okay, I think you will get it. Okay, just check these values. Okay, I have already gave you the values for the each of the integrals. Just you add up all of this, right? So if you add this all of these results, you're going to get this answer only. Okay, anyways, check it again. Please, and make sure that you don't repeat these kinds of mistake, especially in the examination. Okay, because these kinds of question is going to be there in a JEE mains examination, and students generally make mistakes by calculating because the limits of the integral is difficult to calculate and evaluate, and therefore students generally tend to give up. Okay, and they say they have a bigger expression, and then when to club it out, they tend to make silly mistakes. Okay, so please try to avoid those kind of issues. Okay, otherwise all of your effort is going to just go into vain, right? So make sure that you don't take proper care of it and practice more and more these kinds of questions so that you can get more better in this. Okay, so let's proceed with the next problems. Okay, so today we're going to see in general some of the interesting problems, and we're also going to see like how we can going to attack those problems as well, right? So let's start. So let's start with a very interesting problem. So this is the first problem for today's class. Let us say I have to find I have to find the area bounded area bounded by the curve and this curve is given as mod of x plus mod of y. So if I try to look at this problem over here, it's a very simple thing. So if I try to evaluate the expression, let us say I evaluate the expression as mod of y is equals to 1 minus mod of x, 1 minus mod of x, right? Now, now, now let us, and also we have to note that this mod of x is equals to 1 minus mod of y is equals to 1 minus mod of x, right? But you have to note that we already know that the modulus of function of any function is basically greater than or equal to 0. So it is also a positive number, right? And y is also a positive number and x is positive number. So sum of 0, okay, or 0 and 1. I can tell in the both ways, right? So this is has to be ensured. This particular thing has to be ensured because sum of two positive numbers is equals to 1, then both of the positive number has to be less than or equal to 1, right? So that is my take, and from here, so if I solve this first inequality, it is basically saying that x is lying between minus 1 and 1, and similarly your second inequality says that y is lying between minus 1 and 1. Okay, I hope this is clear from the basic idea of the modulus function, right? So once I get the bound of the x and y, now I am basically ready to plot the curve, right? So if I try to plot the curve of this kind of function, so if you look at this particular function, now I'm going to use the case of symmetricity, right? So if you recall in the previous lectures, we have already discussed about the curve symmetricity. That is, if you have this kind of expression of the curve, in place of x, if you replace it with minus of x and the expression remains the same, then it is symmetric about the y-axis, right? It is symmetric about the y-axis. Similarly, if I replace y with minus of y, if I replace y with minus of y and I get the same or similar expression, then it is basically symmetric about the x-axis. So therefore, in this case, it is symmetric about both the x and the y-axis itself, right? So therefore, let me try to plot the curve of this particular function only in the first quadrant, and it will be repeated for the other three quadrants as well, right? So in the first quadrant, both x and y will be positive, and the equation is basically like this: x plus y is equal to 1. So which is a simple straight line where this is 1 and this is also 1. So it is 0 comma 1 and this is 1 comma 0, right? And similarly, since it is symmetric, it is going to repeat like this, and ultimately you're going to have a rhombus. Okay, ultimately you're going to have a rhombus, right? So therefore, if I need to find out, so I have to find out this particular area. I have to find out this particular area. So in order to find out this particular area, I can start with finding out the area of this. Is clear to all of you? Please let me know in the live chat. Okay, I will check this one. Bhaiya, can you teach us straight lines? Yes, I can definitely. I have already discussed about straight lines. Okay, please go back and the playlist. Okay, please watch the playlist. You will find those videos. Okay, I've already covered straight lines for JEE mains, but this year, especially if you are preparing for JEE mains for 2026, I'm definitely going to bring straight lines in the upcoming topics. Okay, so the next topic that is going to be on the line is basically differential equation. Okay, and after that, I'm going to start with the 3D and vector geometry. And once I'm done with all those topics, then I will be starting with the coordinate geometry portion. Okay, so the topics that are basically in line is differential equation, because that is very related to integration. Okay, and after differential equation is done, we will going to start with vectors and 3D geometry, which is a very interesting chapter, very easy, very high scoring topic as well, right? The values quickly, then I think it will be just a piece of cake. Okay, Bhaiya, I am not good in English. You are teaching so fast? Okay, I am extremely sorry, Ektha. I will try to be slow. Okay, I will try to be slow. Okay, so sorry. And also thank you for the feedback, Ektha. Okay, take your time. I am not rushing up. Try to understand this question and then we will proceed to the next problem. Okay, just let me know in the live chat once you're done. Okay, is this clear to all of you? Is this clear? Is this question clear to all of you? Yes, Ekta, it is clear. Great, I'm done. Great. Okay, so let's proceed to another important problems, right? So let me take some example from the previous JEE advanced problems as well. Okay, so that I can show you that what are the types of question that has been asked in the examination and how you are going to solve those questions. Okay, okay, so this is a very interesting problem, and especially if you are not that good with curve sketching, then this question is definitely going to teach you something. Okay, so let me write the question over here. The question is basically find the area, find the area bounded by the region, bounded by the region, by the region y is equal to x square and y is equal to 2 upon 1 plus x square. Okay, y is equal to x square and y is equal to 2 upon 1 plus x square. Okay, so to find the area that is bounded by this particular region, y is equal to x square and y is equal to 2 upon 1 plus x square, right? Okay, so please try to find out this particular area. Okay, just let me know if you have any ideas about how we'll solve this question. Any idea? First of all, what should we do? Whenever we see any general question of finding the area bounded by the curve, the general idea that comes to the mind is basically try to plot the curve of the functions, right? So if you look at the first function, so if I consider this is my first function and this is my second function. So if I look at the first function over here, the first function is given as y is equal to x square, right? So y is equal to x square is nothing but the curve of a parabola, right? So what I'm going to do over here is that let me first try to plot the y is equal to x square curve, right? So if I plot it on the x and y axis, so the y is equal to x square is going to be like a parabola, right? And if you observe, if you change x with minus of x, it is going to become equal to the same expression. So it is symmetric. It is symmetric about the y-axis, right? Which is basically simple parabola, right? Now, the interesting part over here is to draw or sketch the curve y is equal to 2 upon 1 plus x square. Right. Now, this is going to be an interesting curve, right? So, how am I going to do that? Let's try to figure out, right? So, I'm going to do it by very simple methods. What we know we are discussing are basically all real numbers, right? So, x is belonging to real number. That basically means when you take the square of it, it is obviously greater than or equal to 0. Whenever you have any real number and you take the square of it, it is definitely going to be greater than or equal to 0. Right. Now, and in this, if I add 1 plus x square, it is definitely going to be greater than or equal to 1. It is definitely going to be greater than or equal to 1. Right. I hope this is clear. This particular step is clear to all of you. Please let me know in the live chat, yes or no. Is this step clear? Okay. So then if I take the reciprocal of it, now since this particular number is obviously greater than 1, and also it is a positive number, right? It cannot be less than 0, right? It cannot be less than 0, right? So this is a positive number. So 1 upon 1 plus x square will be obviously less than or equals to 1, right? Will be obviously less than or equals to 1. So whenever we have any positive number greater than a, so if I have any positive number greater than a, then 1 upon x is obviously less than 1 upon a, right? If and only if x is greater than 0, right? So please note that if x is a positive number, then I can take the reciprocal and the sign of inequality will change with the reciprocal, right? So that is something that I have applied over here, and then I just need to multiply with 2. So if I just multiply with 2, then I get the same expression, that is 2 upon 1 plus x squared, which will be less than or equals to 2. And it is a positive number, so definitely going to be greater than 0, right? So whatever we are going to get the function as, it is definitely the upper bound of the function is going to be 2 upon x squared plus 1. First of all, let me take the first derivative with respect to x, right? So if I take the first derivative with respect to x, I'm going to get over here minus of 2 upon x square plus 1 and whole square of it multiplied with the chain rule, so it will be equals to 2 times of x over here. So ultimately the derivative is going to be minus of 4x upon x square plus 1 and whole square of it, Is this clear to all of you? Right. So therefore, and this is going to be a first derivative, and I'm going to equate this point to equal to 0 to get the critical points, right? Critical points. So what I observe is that at x equal to 0, the derivative is becoming 0, right? So at x equal to 0, the derivative is becoming 0. Now once I get the critical point, my next job is to find the whether it is a maximum or minimum or not, right? So for that, I'm going to find the second derivative. So if you try to find the second derivative at x equal to 0, this will come out as negative. Right? So what you observe is that the second derivative at x equal to 0 is negative, and the critical point is x equal to 0. That basically means that for this graph y is equal to 2 upon 1 plus x squared, it is having a maxima at x equal to 0. Right. So if I try to plot the graph, it is definitely going to have a maxima at x equals to 0 point, right? And if you look at it, if you put x equal to 0, the maxima is going to be equal to 2, right? And then if you analyze the limiting value at positive infinity and negative infinity, it is going to be equal to 0, because small quantity or finite quantity upon infinity, some finite quantity upon infinity obviously tends towards 0, right? So therefore, at the infinity, it is going to tend towards 0, right? And if you again observe carefully, the curvature is going to be negative, that is concave downwards. Okay, if you take the second derivative and check it within the given limit, you will see that it is for all x values, it is always becoming negative, right? So the curvature is going to be concave down. So the curve is basically going to be like this. Okay, so it is going to be a decreasing curve like this, right? So in the interval x to positive infinity is decreasing, and interval minus infinity to 0, it is increasing, something like this, right? So therefore, ultimately, my region of interest is going to be this. So this is the region or the area that I have to find out in this particular problem, right? So once I draw the curve, now what I can observe is again that again for the second function also, it is symmetric about the y-axis, right? So therefore, if I find out this part of the area and I multiply by 2, then I'm going to get the required answer, right? So let me find out this area. So the area is going to be 2 times of integration 0 to, now how much I will integrate at this particular point. Okay, I will integrate till this point. Let us say this point is A. We will try to find out A as well. So integration 0 to A for the function. So the upper function will be the top one. So it will be going to be coming first, that is 2 upon 1 plus x square minus x square right, and then dx. So this is I have to integrate to get to the area. So I have to integrate this particular function to get the required area, right? Now let me first of all find out that what is going to be the A, right? Why I'm finding out? Because the curve is intersecting at this point and this is the bound of my region, right? This is my bound of my region. So I have to find this point. So in order to find this point, at this point, the value of the y is same for both the equation. So x square should be equated to 2 upon 1 plus x square, right? And if you try to solve it by quadratic approach, you'll get x equals to plus minus 1. So you can see that at x equals to 1 and x equal to minus 1, it is going to intersect, right? Which is again very true because of the symmetricity, because it is symmetric about the y-axis, right? So therefore, the final result of the area, so I have to integrate it to 0 to 1, and if I integrate this result, so if you perform this integration, it is going to 2 times of tan inverse of x. So 2 times of tan inverse of x minus x cube by 3, and the limit is going to be 0 to 1. So if I try to put the limit and I evaluate this result, the final answer to this question, is going to come out as uh, pi minus 2 upon 3, pi minus 2 upon 3 square units. Okay, pi minus 2 by 3 square units. I hope this is clear to all of you. So finally, this is going to be the result. Okay, great, Ekta. Okay, so I hope it is clear to all of you. Okay, and this is a very interesting problem. So sometimes the problems won't be that very simple and straightforward, that you know all the standard function and you will be able to plot the curve of it to get to the area, right? Sometimes the curve sketching is also very important. Now, no one is asking you to draw the exact curve. At least trying to know how the curvature of the curve will change, where the particular curve is having some maxima minima. If you are able to predict those particular values, you will be easily able to solve the questions in the examination as well. Okay, so with this part, I wish the lecture is clear to all of you, right? So definitely we're going to meet up in our upcoming lectures where we're going to discuss more and more questions. Okay, and we're also going to discuss about the JEE advanced previous year problems as well, right? So for that, please stay tuned to this channel and subscribe to the channel to never, and also click the bell icon. Okay, so once you're done with all these things, I hope you are ready with this particular chapter of area under the curve, right? So once you're done with area under the curve, we are going to start in our next lecture or the next day. So tomorrow we're going to start our next lecture or next chapter, that is going to be on differential equation. Okay, so tomorrow there's going to be a lecture on differential equation. So I hope you all are very excited for differential equation, right? Because this is a very interesting chapter and we can visualize a lot of things in terms of physical aspect as well, right? So all the application of science and whatever the principles of world you are studying, is starting from kinematics to the difficult problems of the modern physics, okay, all are a part of a differential equation. So ultimately, as a job as a scientist or an engineer is to finally get the solution of the differential equation, which is not easy to find it out. So all the time the solution or the analytical solution of the differential equation will exist is also not true, right? So with this particular idea, I will conclude my session over here, and I wish to see all of you again in the tomorrow session of differential equation. Okay, so please subscribe to the channel and also hit the like button, as well as share these videos among your friends, your relatives, and your juniors, whoever is preparing for JEE mains and advanced examination or any other competitive examination where the syllabus is basically 10+2 level for CBSE, right? Or any other board as well, right? Just make sure that the syllabus is basically maths, physics, and chemistry. Okay, all right. So with this, I take a leave from this particular lecture. I hope this is clear to all of you. So, and I'm very excited to start the new chapter of differential equation. Hope to see you soon in this next lecture. Okay, bye bye, Ekta. All right, all the best and thank you.